Hello, everyone, and welcome to Psych 409 Human Learning and Cognition. My name is Dr. Mashaki, and I'll be your instructor for the course. Before viewing this PowerPoint, you should carefully read through the syllabus and the entire introduction to the course section on Canvas. For this first chapter, at least, I also recommend that you read the textbook before continuing. Assuming everyone's done that, the first thing I want to emphasize is what information you'll be tested on from the PowerPoints. In this course, information that's in black text on the PowerPoint slides is going to be fair game for the quizzes and exams. Note that this information will also be listed on the study guides as topics that will be covered by the quizzes and exams. And then anything in green text is primarily for examples only and isn't something you'll be directly tested on. Understanding the information in green will certainly help you with the information in black text, but you won't be directly tested on the information in green unless it happens to be listed as a textbook-only topic on the study guide. For example, on today's PowerPoint, a description of operant conditioning is listed in green, but it will be fair game for the quizzes and exams because it is clearly listed on the study guide as a topic from the textbook. Anyway, let's get started on the lecture for Chapter 1. Today I'll be covering an introduction to cognitive psychology, including a brief history of it. I guess the first thing I need to do is to give you a definition of cognitive psychology, and I would define it as an approach to psychology that studies the processes involved in the acquisition, storage, transformation, and the use of knowledge. And during today's PowerPoint, I'll give you a bunch of examples of topics that fall within this category of cognitive psychology. Anyway, to put things into historical perspective, before the 1910s, a lot of topics that would be considered part of cognitive psychology nowadays, like the study of perception and memory, were actively studied by psychologists. But then, as your textbook discusses, Watson and the behaviorists argue that psychology should be the study of observable behaviors and not mental processes like perception, memory, attention, decision-making, etc. And so these topics fell out of favor with American psychologists, at least. This began to change in the mid-1950s when cognitive psychology began to replace behaviorism as the dominant framework in experimental psychology. One way of demonstrating this is to look at the topics that articles in psychology were being published on. This graph shows the number of articles published in what we might call cognitive psychology versus behaviorism from 1950 to 1996. We can see from this graph that it was in the late 1950s and the early 1960s that the number of articles published about topics dealing with cognitive psychology began to increase, while topics about behaviorism began to decrease. So again, a shift in experimental psychology seemed to have taken place in the 1950s and 1960s. The question is why? Why did it occur, and why then? So this is the topic that we're going to concentrate on next. So I'm going to look at 4 reasons why cognitive psychology displaced behaviorism as the dominant paradigm in experimental psychology. The first reason was a general dissatisfaction among behaviorists with the restrictions of behaviorism. That is, many findings were better explained by referring to mental processes, which the traditional behaviorist perspective didn't allow. Remember from the textbook that Watson, a leader of the behaviorists, said that psychology should be the study of observable behaviors and shouldn't make references to mental processes like memory, perception, and consciousness. For example, behaviorists are traditionally associated with the studies of rats and maze learning, where a rat will be placed in a maze and given a chance to explore it before finding a food reward at the end of the maze. This process is repeated multiple times, and each time the rat finds the food reward faster. The question is, how does the rat come to learn the maze? How does it learn the fastest path to get from the start box to the food reward? A traditional behaviorist explanation for learning that your textbook talks about is operant conditioning, which says that reinforced behaviors will be repeated in the future. So if the question is, when a rat gets to a particular intersection in the maze, how does it know to turn right to get to the food? A behaviorist would say, well, every time it reached that intersection in the past, it turned right and was rewarded by eventually finding the cheese. And so the rat learned that when I get to the intersection, I should turn right. That was the behavior that was reinforced. But not all psychologists, including some behaviorists, were satisfied with these purely behavioral explanations for behavior, and they believed that animals, even lowly rats, exhibited mental processes. One behaviorist who believed this was Tolman, who argued that behaviors of rats exploring mazes reflected knowledge and expectations, that is, mental processes. He presented data which suggested that when rats learn a maze, what they are actually learning is the spatial layout of the maze, not which direction to turn when they get to a certain intersection. In other words, he argued that rats form a cognitive map of the maze. Notice that this explanation for rats' behavior makes references to unobservable mental processes and thus isn't in line with the traditional behaviorist explanations. So first, let me give you a couple examples of Tolman's studies which do seem to suggest that rats form a cognitive map of the maze. In this first study, rats began by being placed in the start box. They then had a chance to explore the maze and they eventually found food at the end. This was repeated for many trials until the rats learned the route that would take them from the start box to the goal box the fastest. Then Tolman did something tricky. He added this new passage to the maze. The question was, how would rats turn when they come to this intersection? The traditional behaviorist prediction was that because rats were always rewarded for turning right and were never rewarded for turning left in the past, they should continue to turn right. However, if Tolman was correct and rats formed a cognitive map of the layout of the maze, they should turn left, as that would get them to the food the fastest. And that's exactly what Tolman found. The rats are more likely to turn left than to turn right. Again, this suggests that rats' behavior is based on more than just basic operant conditioning, that it reflected expectations, knowledge, and other cognitive processes. In a second study, Tolman gave rats a chance to explore a maze that looked like this, and then after the rats were familiar with it, he placed food in Area B. So the rats were placed in Area A, and then they quickly learned to turn right at this central intersection to find the food. But then in the final part of the study, Tolman did something tricky again. He essentially rotated the maze by 180 degrees, and so the rats started in box C instead of box A. Again, the question is, how would the rats behave when they reached the central intersection? Behaviorists would predict that the rats would turn right as they had been reinforced for making a right turn in the past when they arrived at that intersection. However, if the rats truly did form a cognitive map of the maze, then they should turn left, as that would get them to the food the fastest. And what Tolman found again was that yes, the rats were more likely to turn left, suggesting that they had formed a cognitive map of the maze. So, to summarize, the first reason that cognitive psychology displaced behaviorism was a general dissatisfaction with the restrictions of behaviorism that prevented psychologists from referring to mental processes. For instance, the results of Tolman's studies was that rats turned in the direction that would get them to the food the fastest, as if they had formed a mental cognitive map of the maze, not in the direction they were previously reinforced for turning, as behaviorist theories would predict. And so this implies that behaviorist explanations that prevented psychologists from referring to mental processes to explain learning were too restrictive. A second reason that behaviorism was displaced by cognitive psychology was that behaviorists were completely unable to explain the learning of certain complex behaviors, particularly language. For example, in one of his more famous books, Verbal Behavior, Skinner argued that language was just like any other behavior and that it was learned through the results of reinforcement and punishment. He claimed, for example, that children imitate speech they hear, and correct speech is rewarded and repeated, and so that's how children come to learn language. However, a cognitive scientist named Noam Chomsky attacked Skinner's book in a scathing book review. Nowadays, if you don't like a book, right, you might hop on Amazon and write a nasty 200-word review. Chomsky's review was much worse than that. He wrote a 33-page criticism of Skinner's book. This is one of the few times in history where a review of the book was more influential than the book itself. Anyway, your textbook describes Chomsky's criticisms on page 12, so I won't repeat them here, but it argued very convincingly that complex behaviors like language simply can't be explained by purely behavioral concepts like reinforcement and punishment, and require referring to mental processes to fully explain them. A third reason that cognitive psychology displaced behaviorism was that cognitive theories and explanations had greater applicability to other domains. For example, the design of airplanes was thought to be a purely physical problem. In other words, as long as the plane was engineered well, any pilot should be able to fly it, and all planes should be equally easy to fly. It turned out, however, that this was a naive view. Just like certain computer programs and products are harder to use than others, certain airplane designs cause problems. For example,
One plane in World War II had a very high rate of landing accidents compared to other similar planes. It turned out that this was because the lever to lower the landing gear was adjacent to the lever for putting on the brakes. So instead of pulling the lever for the brakes after the plane landed, pilots would often pull the landing gear lever instead, which would retract the wheels and cause the plane to land on its belly. This could have been avoided if the controls were on either side of the pilot, so the pilot used one hand to lower the landing gear and a different hand to put on the brakes. The point is, it is easier to explain this problem using cognitive processes than trying to explain why rewards or punishment should make one design more difficult to use than another. Air Force mechanics didn't care that things like memory or attention were unobservable concepts when their pilots were crashing multi-million-dollar airplanes. They wanted a better way of understanding human behavior, which cognitive psychology provided. The fourth reason that behaviorism was displaced was the creation of the digital computer and the computer metaphor for the brain. The first digital computers were created in the 1940s, but they weren't widely used until about the late 1950s. Around this time, psychologists started to talk in terms of a computer metaphor for the brain. There are two questions we need to look at regarding the computer metaphor. The first one being, what is it? Well, this is pretty simple. The computer metaphor for the brain is just that the brain is like a computer. Now, nobody actually believes that humans physically resemble digital computers, that we have silicone chips in our heads, but the idea is that humans have to solve many of the same sorts of problems that machines do, and they seem to do so in similar ways. Specifically, both brains and computers are information processors that process information in stages and produce responses based on input. So specifically, both brains and computers take in information from the environment, either through our senses for humans or through the mouse and keyboard for machines. Both humans and computers process the information internally, our mental processes for humans or computer programs for machines, and then we produce some output, either behavior for humans or some sort of output for the computer. So that's what the computer metaphor is, that the brain is like a computer. The second question is, why was the computer metaphor important? And the answer is, the computer metaphor provided a scientifically respectable way of describing, and hence it legitimized the study of mental processes. The argument being, if the brain is like a computer, and it's not unscientific to describe computers as having unobservable processes, then why not for humans? So the point here is that computers can be said to have or to do lots of things, even though we can't directly observe those processes in the computer. Computers have memory, computers can perform math problems, computers can recognize speech through voice recognition software, and it's not unscientific to say that computers can do these things. And so, if brains are like computers, and it's not unscientific to talk about computers having memory, or making decisions, or having speech recognition, then cognitive scientists argue that it shouldn't be unacceptable to say that humans have unobservable mental processes like these either. The last thing I want to talk about today are three key assumptions of cognitive psychology. The first key assumption is that mental processes like perception, memory, imagery, language, etc. are real and important. Remember, for behaviorists, they claim that mental processes either weren't real, they didn't exist, or they weren't important. For example, Watson said that thinking is really just subvocal motor movements, basically really quiet whispers. So notice that many of these mental processes here would be off limits in terms of being studied by behaviorists, or they would be studied in a much different way than they are studied nowadays. Now, this sort of begs the question though, how can we study mental processes when we can't see them? To answer this question, I'm going to have us do a couple demonstrations. For the first demonstration, I'm going to read you a list of letters, and I want you to repeat them back to me. Okay, here's the first list. T, D, G, Z, P, C, V. Okay, try to repeat those letters back to me. Now, if you're anything like the students in my face-to-face class, you probably had some trouble with that list of letters. So let's try a second list of letters and see if that's any easier for you. Okay, here's the second list. L, K, S, W, R, Q, N. Okay, repeat those letters back to me now. And I bet the second list was much easier for you to remember than the first list. Now, what this demonstration shows us is that the unobservable mental process of memory stores information based on what it sounds like versus, for example, what the information looks like. This is why it's more difficult for you to remember the letters from list 1 versus the letters from list 2, because in list 1, all the letters sound similar to each other, and so it's difficult to keep them apart in memory. So, how do we learn this fact about memory, that it stores information based on what it sounds like, when we can't directly observe memory? Well, we learn this information by studying your observable responses, specifically your ability to remember the information. Donder's study from the textbook provides another good example of this, of how we can use people's observable responses or behaviors to learn something about mental processes, in this case, the mental process of decision making. Let me give you one more example, which is my favorite example in all of psychology. So, in class, I have students raise their hand if it looks like these two squares, A and B, are different colors. And of course, everybody does, because yeah, it looks like A and B are different shades of gray. However, when I add in these lines here, we can see that A and B are actually the exact same color. They're the same shade of gray. This example shows that our brain doesn't just take in information from the environment and produce an exact representation of what is in the environment. Instead, it uses certain processes to interpret the information. Specifically, you perceive B to be lighter than it actually is because it looks like B is in a shadow, which will make it appear darker to you. So your brain has a mental process that compensates for this assumption that B is in a shadow, causing it to look lighter to you than it actually is. This brings us to our second point, that mental processes and their properties can be studied scientifically by studying people's observable behaviors, even though the mental processes themselves can't be directly observed. So, by studying people's responses through demonstrations like these, as well as more rigorous experiments that we'll talk about throughout the semester, cognitive psychologists are able to show that mental processes are real, and that again we can learn about these mental processes by studying people's observable behaviors. The last key assumption of cognitive psychology is that the level of analysis is separate from the brain or neuroscience. That is, cognitive psychologists study the mental processes produced by the brain, not the physical brain itself. So yes, neuroscience has definitely played a role in cognitive science, particularly more recently as their techniques have become more advanced. The point I want to make here, though, is that cognitive psychology and neuroscience are different because we study different things. Now, to be clear, that doesn't mean that mental processes don't come from the brain, because they definitely do. What I want to emphasize, though, is that cognitive psychologists, I guess I would say, are more interested in the results of brain processes rather than the physical hardware of the brain itself. For example, we're more interested in how people remember than the areas of the brain involved in memory. And again, just like we demonstrated, we don't have to study the physical brain itself to understand mental processes. We can study people's behaviors to do this. Anyway, that's all I have for you today. Don't forget to take quiz number 1. Do the same stuff for chapter 3 that you did for chapter 1, and then do the question and answer posts on the discussion board. And if you have any questions about this course, please do post them on the discussion board, and I'll be happy to answer them.